I am Vijay from Space Application Center, and today I am going to present the video aspect of our work on modified CEMIC scheme for multiplexing signals over single frequency band. And this work is basically based on the multiplexing of multiple signal over single frequency band, and it is going to published in this fall session of our Navigation Journal of Institute of Navigation. Uh, like navigation payload is generally configured to transmit multiple signal over common RF payload channel. They are actually doing so to support various services over using single transponder. So it is desired that the signals that are actually multiplexing should not interfere to each other. The mutual interference should be as minimum as possible. And it is desired that the transponder should operate in the saturation region so that maximum power should be derived from the transponder. And in order to do so, the criteria of constant envelope of the composite signal is required. Like the composite signal that are generating after multiplexing, all the signals should be constant so that the transponder should be operated in the saturation region. And in today's, like all the GNSS operator actually are using spread spectrum methods to modulate their narrow band signal, using wideband codes. So they are doing so to get the spreading gain. Typically, the received signal should be below the noise floor. So in order to receive them properly, spreading gain is required. So it is like by doing so, they are ensuring also like the signals is not having mutual interference because these codes are orthogonal to each other. So in order to actually multiplex this signal, one of the easiest ways is the direct superposition that directly add this signal at the baseband level. But the thing is, in that case, like the envelope is not guaranteed to be constant. It may have actually high PAPR that will force the transponder to operate in the back off region, and will not be able to derive actually maximum power from the transponder. And these are the actually critical design aspects actually that we have considered in our work. Like first already mentioned that the envelope should be constant, so that the complete transponder at high power amplifier of the transponder should be operated in the saturation region to derive maximum power. Another and most important factor is backward compatibility, in which we are assuring that in this particular case, like the receivers that are already operational in the field, for the existing signal should not be actually interrupted by adding the new signal. We are adding new signal and we are actually making it and easy actually transition from the for the receiver, because it will be a receiver transparent method, so receiver will not be interrupted at all. And another important thing is like spectral compatibility. Like in this aspect, we are actually trying to optimize the modulation and of the signal so that it should not interfere to the existing signal. So these are the following research gap that we have actually find out when we are actually doing this work. The typical general CEMIC scheme is actually using the intermodulation signal power only to maximize the efficiency. That they are minimizing the intermodulation power and then they are actually maximizing the efficiency. But in our case, we have proposed a new cost function in which we are actually not only we are minimizing the this intermodulation power, but we have already added a new dimension. Like we are actually minimizing the deviation of the power of the existing signal also in this work, so that by using these two actually cost function, we are getting better efficiency from the existing method. And another important dimension of our work is that the support of the backward compatibility, that we have added the constant based on the backward compatibility, so that the relative power sharing and the phasing of the existing signal is preserved, and the receivers that are already operational in this on the field for the existing signal should not actually interrupted. And thank you for listening this presentation. Hope you'll enjoy reading our work at IN Navigation Channel.